The world has seen many incredible fighter jets, each marking a chapter in aviation history. From the roaring engines of past warbirds to the sleek, high-tech machines of today, each new generation has pushed the limits of speed, power, and innovation. But now something far beyond a simple upgrade is coming. Something that will redefine air combat forever. The Tempest fighter jet is not just another aircraft. It represents a new era in aviation. It is designed to be smarter, faster, and deadlier than anything that has ever taken to the skies. Every aspect of its creation is focused on one goal: absolute air superiority. The United Kingdom has a proud legacy of aviation excellence, with aircraft that have shaped the course of history. During World War II, the Spitfire dominated the skies, protecting the nation in its darkest hour. In later years, jets like the Harrier jump jet changed warfare with their ability to take off and land vertically. More recently, the Eurofighter Typhoon has guarded Britain's skies with unmatched agility and speed. But now the Tempest is set to go even further, not just leading the next generation of fighter jets, but defining it. What makes Tempest different is not just its stealth capabilities, advanced weapons, or unmatched speed. It is how it thinks, adapts, and fights like no jet before it. It will have an AI-powered co-pilot capable of processing battle data in real time and making split-second decisions faster than any human ever could. Its self-healing systems will detect and fix minor issues before they even become a problem, ensuring that it stays in peak condition even during intense missions. For military veterans who have spent their lives defending the skies, this jet is a symbol of pride and progress. It represents how far aviation has come, from the days when pilots relied only on their instincts to a future where technology and human skill work together for ultimate dominance in the air. It also ensures that future pilots will have the best possible tools to complete their missions and return home safely. For aviation enthusiasts, this is more than just a new fighter jet. It's a once-in-a-lifetime leap in technology. The Tempest will redefine what a fighter jet can do, setting new standards in speed, stealth, and intelligence. This isn't just about making a better aircraft. It's about creating the future of air warfare. The legend of British aviation is about to take its next great step forward. The Tempest is coming, and when it does, the skies will never be the same again. For decades, fighter jets have evolved, becoming faster, stealthier, and deadlier with every new generation. But now something truly revolutionary is taking shape. Unlike any aircraft before it, this new war machine is not just an improvement, it is a complete transformation of air combat. Stealth has always been crucial in aerial warfare, but older stealth jets have their limitations. The latest fighter jet takes stealth to an entirely new level. Its special radar-absorbing materials make it nearly invisible to detection systems, while its advanced heat-reducing technology minimizes its infrared signature, making it difficult for enemy heat sensors to track. Unlike traditional aircraft that reflect radar waves, its sleek, sharp-edged design absorbs and deflects signals, making it incredibly hard to detect. Even against modern radar systems, this jet has an edge, allowing it to operate deep inside enemy territory without ever being seen. Speed and agility are just as important as stealth, but many aircraft sacrifice one for the other. This new war machine, however, is designed for both. It achieves supersonic speeds without needing an afterburner, which not only saves fuel, but also increases range. This means it can fly faster for longer while maintaining efficiency. The combination of powerful twin engines and lightweight composite materials allows it to outmaneuver almost any opponent, making it one of the most agile and unpredictable fighters ever built. Advanced warfare requires intelligence, not just firepower. Pilots today face an overwhelming amount of information, from radar signals to enemy movements, and every decision needs to be made in an instant. This fighter jet changes the game by incorporating an AI-powered combat assistant. Instead of relying purely on human reflexes, the onboard AI acts as a co-pilot, analyzing the battlefield in real time, predicting enemy movements, and offering tactical recommendations. This system processes data faster than any human could, allowing pilots to stay ahead of the fight. If a pilot becomes overwhelmed in combat, the AI can temporarily take control, assisting with evasive maneuvers, targeting enemy aircraft, and even responding to threats before they become a danger. Traditional fighter jets need constant maintenance and repairs, often grounding them for long periods. This aircraft, however, is self-healing. Smart sensors are embedded throughout the airframe, constantly monitoring for any potential damage. If something goes wrong, the jet automatically reroutes power, adjusts flight controls, and even repairs minor structural issues on its own. This makes it far more reliable and durable than older jets, ensuring it can continue operating even after sustaining damage. Firepower is just as critical as stealth and speed. This fighter is designed to carry next-generation weapons that give it an overwhelming advantage in combat. High-speed missiles can lock onto multiple targets at once, increasing the chances of a successful hit. Energy weapons, such as high-powered lasers, are being developed to eliminate threats instantly without using traditional ammunition. Hypersonic weapons, capable of traveling more than 5 times the speed of sound, ensure that enemies have virtually no time to react. Unlike older jets that store their weapons on external hardpoints, increasing drag and radar visibility, this aircraft conceals its weapons inside an internal weapons bay, maintaining its stealth profile while carrying a devastating arsenal. Modern warfare isn't fought by a single aircraft alone, and this is where this new fighter changes everything. Instead of operating as a lone warrior, it is designed to command a fleet of unmanned combat drones, also known as loyal wingmen. These drones can fly ahead, scouting enemy positions, jamming enemy radar, or even engaging in combat themselves. They can also act as decoys, drawing enemy fire away from the main jet. If needed, they can be sacrificed to protect the human pilot, ensuring mission success with minimal risk. This completely changes how air battles are fought, allowing one pilot to control an entire squadron of intelligent, robotic aircraft. One of the most mind-blowing features of this fighter is its ability to predict the battlefield before it even enters combat. Its onboard AI continuously gathers data from satellites, other aircraft, and ground-based intelligence. It then builds a complete picture of the battle before the pilot even takes off. This means that pilots will know where the enemy is, what their strategy is, and how to counter it, all before they even engage in combat. When multiple jets of this kind fly together, they form a networked intelligence system, sharing information instantly, making them unstoppable in battle. Everything about this aircraft is designed for domination. It is invisible to enemy radar, smarter than any jet before it, faster and more efficient, loaded with advanced weapons, and able to control robotic drones. It's not just another fighter jet, it's a revolution in air combat. While the rest of the world continues to upgrade their current jets, this war machine is leaping ahead, setting a new standard for the future of aerial warfare. The skies are changing, and this aircraft is leading the way into a new era of air superiority. Throughout history, the greatest advancements in military technology have come not from a single nation working alone, but from powerful alliances combining their strengths. The most advanced fighter jet in development today is no exception. It is the result of an unprecedented partnership between 3 technological powerhouses: the United Kingdom, Japan, and Italy. This collaboration is not just about sharing resources. It is about merging the best minds, industries, and innovations from 3 nations to create something that no country could achieve on its own. The United Kingdom brings a long history of fighter jet dominance. From the legendary Spitfire in World War II to the cutting-edge Eurofighter Typhoon, British engineers have consistently designed aircraft that set new global standards. The UK's aerospace industry has decades of experience in developing stealth, supersonic performance, and electronic warfare capabilities, making it a leader in modern fighter jet technology. Additionally, Britain has been a pioneer in advanced pilot interfaces, including augmented reality helmet displays and AI-assisted flight controls. These technologies ensure that future fighter pilots will have an unmatched level of battlefield awareness. Japan's contribution is equally critical. Known for its world-class electronics, robotics, and artificial intelligence, Japan is bringing advanced sensor fusion technology, which allows an aircraft to collect, process, and share massive amounts of battlefield data in real time. This technology ensures that pilots receive instant feedback on enemy movements, missile threats, and terrain awareness. allowing them to anticipate attacks before they even happen. Japan's mastery in miniaturization and high-efficiency computing means that the jet's AI systems are incredibly fast, intelligent, and power-efficient. Moreover, Japan's experience in autonomous systems will help integrate unmanned combat drones, allowing the jet to command a squadron of robotic wingmen that can fly alongside it in battle. Italy has a well-earned reputation for its superior aerospace engineering and materials expertise. Italian companies specialize in lightweight composite materials that are both extremely strong and resistant to high temperatures and stress, making them perfect for high-performance jets. These materials ensure that the aircraft is not only durable and resilient in extreme combat conditions, but also lightweight enough to maintain superior speed and agility. Italy is also contributing to next-generation propulsion systems, ensuring that the aircraft can sustain high speeds without excessive fuel consumption. Additionally, Italy's defense industry has perfected aerodynamic designs that reduce drag and improve fuel efficiency, allowing this aircraft to operate with maximum performance over long distances. This partnership is more than just technological cooperation. It is a strategic alliance that strengthens global defense capabilities. In today's rapidly changing world, nations cannot afford to fight future wars alone. Threats are becoming more complex, and air combat is evolving beyond traditional dogfighting into a battlefield dominated by electronic warfare, stealth capabilities, and AI-driven decision-making. By working together, the UK, Japan, and Italy are ensuring that they remain ahead of potential adversaries who are also developing next-generation fighter jets. This international collaboration also brings significant advantages in cost reduction and production speed. Fighter jets are among the most expensive military projects in the world, requiring billions of dollars and decades of research and development. By splitting the investment and sharing technological expertise, these three nations are reducing the financial burden while accelerating the aircraft's development. Instead of one country shouldering all the risks and costs, this project benefits from a combined budget, talent pool, and industrial resources that allow it to be completed faster and more efficiently. Beyond military strategy, this collaboration is setting the stage for a new era of global defense partnerships. Unlike past aircraft programs that were limited to one country's military, this jet is designed to be adaptable for multiple allied nations. This means that future partners can customize the aircraft to fit their own military needs, making it a highly versatile and widely used fighter jet across different regions. This ensures that allied air forces can operate seamlessly together, creating a stronger, more unified air defense network across multiple continents. One of the most groundbreaking aspects of this collaboration is how each country's industry is benefiting from shared research and innovation. Technologies developed for this fighter jet are not limited to military use. Many of the advancements in AI, material science, and energy-efficient propulsion will also impact civilian industries. From commercial aviation to autonomous vehicles and high-performance computing, the breakthroughs from this project will push global technology forward in ways that extend far beyond the battlefield. This partnership is also a powerful statement on international security and deterrence. In a time when air superiority is more important than ever, having a state-of-the-art fighter jet signals to the world that these three nations are committed to maintaining global stability and security. Potential adversaries will think twice before challenging a coalition that possesses one of the most advanced war machines ever created. The collaboration between the United Kingdom, Japan, and Italy represents a bold new direction in military aviation. It combines the best of British aerospace engineering, Japanese artificial intelligence and robotics, and Italian materials expertise to create a fighter jet that will dominate the skies for decades to come. This project is not just about building a war machine, it is about shaping the future of global air power. By working together, these three nations are ensuring that their skies and the skies of their allies remain secure in the face of any challenge. The future of air combat is no longer about one nation leading the way. It is about global cooperation, shared innovation, and a commitment to staying ahead of the competition. The cockpit of a fighter jet is more than just a seat surrounded by controls. It is the nerve center of the aircraft, where every critical decision is made in milliseconds. Over the decades, cockpits have evolved from simple gauges and dials to highly digital interfaces with touchscreen controls and heads-up displays. But now a new era has begun. The latest fighter jet is being designed with the most advanced cockpit in aviation history, one that thinks, reacts, and adapts to the pilot's needs like never before. Traditional cockpits require pilots to constantly scan instruments, adjust controls, and interpret multiple sources of data, all while flying at supersonic speeds and engaging in intense aerial combat. This is an overwhelming task, even for the most experienced pilots. But this next-generation cockpit is designed to reduce the pilot's workload, allowing them to focus purely on the mission while the aircraft handles the complex data processing. At the heart of this new cockpit is an artificial intelligence, AI, co-pilot, an advanced system that functions like an additional brain inside the aircraft. This AI constantly monitors the battlefield, detects threats, analyzes enemy patterns, and offers real-time tactical suggestions. If the pilot is overloaded, the AI can automatically adjust flight paths, manage electronic warfare countermeasures, and even assist in targeting enemy aircraft. This level of automation is revolutionary, as it allows pilots to make faster, more precise decisions without getting distracted by information overload. One of the most groundbreaking features of this cockpit is the augmented reality AR helmet display. Traditional fighter jets rely on heads-up displays, HUDs, projected onto glass panels in the cockpit. But this new system removes the need for physical screens altogether. Instead, the pilot wears a high-tech helmet that acts as a complete digital interface, projecting mission-critical data directly onto the visor. This helmet does more than just display information. It allows the pilot to see through the aircraft. Advanced sensors and cameras feed real-time visuals into the helmet, giving the pilot a 360-degree view of the battlefield. This means they can look through the floor of the aircraft, behind them, or in any direction without relying on mirrors or turning the jet itself. If an enemy aircraft is approaching from below or behind, the pilot will see it instantly, eliminating blind spots that have traditionally been a major weakness in air combat. This level of situational awareness is game-changing. Imagine flying at Mach 2, surrounded by enemy aircraft, while dodging missiles and countering electronic attacks. A traditional pilot would have to manage radar, infrared sensors, communications, and weapon systems all at once. But with this advanced cockpit, the pilot can simply turn their head to see everything they need in real time. The AI system highlights threats, calculates escape routes, and even suggests which weapons to use for maximum efficiency. It's like having a superhuman sixth sense, allowing pilots to react faster than ever before. But the real innovation comes in how pilots control the aircraft. Older jets rely on joysticks, buttons, and switches, requiring pilots to physically interact with controls while in combat. This new cockpit, however, introduces gesture-based controls and voice commands. Instead of pressing a button, the pilot can simply move their hand in the air to switch weapon systems, lock onto a target, or activate countermeasures. This gesture tracking technology works similarly to modern VR headsets, but is designed for the extreme conditions of aerial combat. Voice commands take this a step further. The AI system recognizes spoken instructions, meaning a pilot can issue complex commands without ever taking their hands off the controls. For example, instead of manually adjusting sensors or targeting systems, the pilot can simply say a command, and the AI will execute it instantly. This eliminates the need to memorize complex sequences of buttons, reducing stress, and allowing pilots to focus on combat strategy rather than control inputs. The flight controls themselves have also been reimagined. Traditional jets rely on mechanical linkages that physically connect the pilot's inputs to the aircraft's control surfaces, while modern jets have introduced fly-by-wire systems, which use electronic signals instead of cables. This next-generation fighter goes even further with brainwave-controlled assistance. Electroencephalogram (EEG) sensors built into the pilot's helmet can detect brain activity and interpret intent, allowing the aircraft to anticipate movements even before physical inputs are made. While the jet won't be entirely mind-controlled, this technology allows for split-second reactions, helping pilots maneuver the aircraft with unparalleled precision. If a pilot is about to execute a high-speed turn or evasive maneuver, the aircraft system can detect the intention and adjust controls instantly, making movements smoother, faster, and more precise. Another major advancement is the integration of biometric monitoring systems. Combat situations are physically and mentally demanding, often pushing pilots to their absolute limits. This fighter jet continuously monitors the pilot's heart rate, stress levels, oxygen levels, and cognitive function. If the system detects that the pilot is fatigued, stressed, or experiencing reduced performance, it can adjust controls, provide automated assistance, or even take over critical functions until the pilot recovers. This technology is crucial for long missions and high-G maneuvers, where pilots are subjected to extreme forces that can cause temporary loss of vision or consciousness. If a pilot loses control due to G-forces, the AI can instantly take over, stabilizing the aircraft and preventing a crash. In emergencies, the cockpit can automatically deploy countermeasures, evade incoming missiles, or even guide the aircraft back to base safely. This ensures that pilots are protected not just by armor and countermeasures, but by a system that actively looks after their well-being. The navigation and communication systems have also been completely reimagined. Instead of relying on traditional radar and radio systems, the aircraft uses quantum-encrypted satellite communication, ensuring completely secure transmissions that cannot be hacked or intercepted. This technology allows the jet to coordinate with other aircraft, drones, and ground forces in real time, creating a fully connected battlefield where every asset works together seamlessly. A major advantage of this cockpit design is its adaptability. Unlike older jets, where cockpit layouts are fixed and require costly modifications to update, this next-generation cockpit is fully customizable through software updates. Pilots can rearrange digital displays, customize information overlays, and even adjust how the AI interacts with them, making it the most flexible fighter jet cockpit ever built. Beyond combat, this technology has implications for training and pilot development. In traditional pilot training, recruits spend years mastering complex aircraft controls. But with AI-assisted cockpits, intuitive augmented reality interfaces, and simplified control systems, pilots can train faster and operate more effectively. Future generations of fighter pilots will no longer be limited by outdated mechanical controls. They will be equipped with a system that adapts to their needs, enhances their abilities, and provides real-time combat intelligence. With all these advancements, this is more than just an aircraft. It's a flying command center that merges human skill with artificial intelligence, cutting-edge technology, and futuristic control systems. It ensures that pilots are always aware, always in control, and always ahead of the enemy. No cockpit in history has ever been this advanced, and no fighter jet has ever given its pilots so much power, precision, and battlefield awareness. This is not just an evolution in fighter jet design, it is a revolution in aerial warfare. With unmatched AI support, mind-reading controls, augmented reality vision, and biometric protection, this cockpit ensures that the pilot and the machine become one, creating the ultimate combat system in the sky. This is the future of air superiority, and it is about to take flight. For decades, military aviation has been defined by speed, firepower, and maneuverability. But in today's rapidly evolving battlefield, raw power alone is no longer enough. The real game changer is intelligence, the ability to see before the enemy sees, react before the enemy reacts, and strike before the enemy even knows they are in danger. This is where the latest fighter jet takes air combat to an entirely new level, thanks to a secret technology that changes everything. At the core of this breakthrough is a next-generation artificial intelligence, AI, combat system. Unlike traditional fighter jets that rely solely on human pilots, this jet thinks for itself, acting as both an advanced co-pilot and a tactical command center in the sky. The AI can predict enemy movements, analyze massive amounts of battlefield data, and react instantly to changing combat conditions. While human pilots are limited by reaction speed and cognitive overload, this system can process information in milliseconds, allowing for faster and smarter decisions than ever before. One of the most astonishing capabilities of this technology is predictive warfare analysis. Using advanced machine learning, the AI studies past battles, real-time combat situations, and enemy tactics to predict what the enemy will do next. This means that before an enemy aircraft even launches an attack, This fighter jet has already anticipated it, prepared a counter strategy, and positioned itself for an advantage. In high-speed aerial combat, where decisions must be made in the blink of an eye, this kind of foresight is an absolute game changer. This AI-driven intelligence system is deeply integrated with quantum computing, a revolutionary technology that allows data to be processed at speeds far beyond anything previously possible. In traditional computing, data is processed in a linear fashion, but quantum computing allows for simultaneous multipath processing, meaning the system can analyze thousands of potential battle scenarios in real time. This enables the fighter jet to calculate the best possible course of action faster than any human or traditional AI could. But what truly sets this aircraft apart is its ability to operate as part of a digital swarm. Modern warfare is no longer fought by a single aircraft or a single pilot. It is a network battlefield where multiple assets work together. This jet is designed to connect and communicate seamlessly with other fighter jets, drones, satellites, and ground forces, creating a shared intelligence network that provides a real-time picture of the battlefield. Imagine multiple fighter jets flying together, each one instantly sharing data, sensor readings, and enemy locations with the others. This effectively turns a squadron into a single, unified combat force that moves with near-perfect coordination. A key part of this strategy is the loyal wingman drone system. This jet doesn't fly alone. It commands a fleet of AI-powered unmanned aerial vehicles, UAVs, that act as its support team. These autonomous drones can be used for reconnaissance, electronic warfare, or direct attack missions. If enemy aircraft are detected, the pilot can send in the drones first to draw fire, confuse enemy sensors, or engage in combat, protecting the manned jet while still striking hard. These drone wingmen can also be equipped with their own AI systems, meaning they can act independently, adapt to threats, and carry out high-risk maneuvers that human pilots would never attempt. Another secret capability of this fighter jet is its adaptive electronic warfare suite. Traditional fighter jets rely on stealth coatings and radar-absorbing materials to remain undetected. But radar technology is constantly improving, making traditional stealth less effective over time. This new aircraft, however, takes a different approach. It doesn't just try to hide from enemy sensors, it actively fights back against them. Using artificially intelligent jamming systems, the aircraft can detect and manipulate enemy radar signals in real time, making itself appear invisible or even tricking enemy sensors into thinking it's in multiple locations at once. This goes beyond stealth. It turns the aircraft into a ghost in the sky, impossible to track, target, or lock onto. It can also hijack enemy communications and radar systems, disrupting their ability to coordinate attacks or detect incoming threats. This technology extends beyond the battlefield, offering unprecedented cyber warfare capabilities. With integrated electronic attack modules, the aircraft can launch cyber strikes against enemy defense networks, disable missile guidance systems, and even disrupt entire air defense grids. This means that in a future conflict, it won't just be about who has the best jets. It will be about who controls the digital battlefield. With the ability to neutralize enemy defenses before even engaging in direct combat, this jet ensures that the enemy is always on the back foot. Another major breakthrough is the adaptive weapon system, designed to handle multiple types of advanced weaponry, including next-generation hypersonic missiles and energy-based weapons. Traditional fighter jets are limited by the types of weapons they can carry, but this aircraft's modular system allows it to switch loadouts depending on the mission. For example, hypersonic missiles. These missiles travel at speeds faster than Mach 5, making them nearly impossible to intercept. This jet is specifically designed to launch and guide hypersonic weapons, giving it the ability to strike targets across vast distances in record time. Directed energy weapons. Laser-based weapons, once considered science fiction, are now becoming reality. This jet is being equipped with high-powered lasers capable of destroying enemy drones, missiles, and aircraft instantly without needing traditional ammunition. This means endless firepower as long as the aircraft has energy to spare. Electromagnetic railguns. This experimental technology allows the jet to fire hypervelocity projectiles using magnetic force, giving it a silent, supersonic strike capability that is both incredibly powerful and nearly impossible to defend against. Beyond its weapons, this aircraft introduces a new concept: real-time battlefield adaptation. Traditional fighter jets are built with fixed hardware, meaning they require physical upgrades to improve performance. This jet, however, is designed to update itself through software enhancements, meaning it can improve its combat capabilities over time without requiring costly modifications. New AI algorithms, electronic warfare tactics, and even new flight control methods can be uploaded remotely, ensuring that this aircraft remains cutting edge for decades. The cockpit itself is another part of this secret technology. It is equipped with a neural interface that allows the pilot to control certain functions using brainwave signals. While full mind-controlled flight is still in development, the system can already detect stress levels, cognitive load, and intention, allowing the AI to assist the pilot in ways never before possible. If the system detects that the pilot is overwhelmed, fatigued, or in distress, it can temporarily take over flight control, adjust breathing assistance, and even issue emergency countermeasures automatically. This ensures that even in the most extreme combat conditions, the pilot has a second layer of protection that increases survival chances dramatically. This is not just a fighter jet, it is a revolution in aerial warfare. It is designed to dominate in every aspect of combat, from stealth and cyber warfare to AI-driven decision-making and next-generation weaponry. It is a thinking machine, a digital battlefield commander, and a deadly hunter, all in one. While the world is still catching up to fifth-generation fighter jets, this aircraft leaps ahead into the next era, defining the future of air combat for the next 50 years. With this fighter jet in the skies, wars will no longer be fought the way they used to be. The battlefield is changing, and this aircraft is at the center of it all. The secret is out. Air superiority has just been redefined. For over a century, the battle for air superiority has shaped modern warfare. The country that dominates the skies holds the power to control battlefields, protect its homeland, and strike anywhere in the world within minutes. But now the game is changing faster than ever. The world's most powerful nations are engaged in a new kind of arms race, one where the winner will not just build the fastest or most powerful jet, but the smartest, most advanced war machine ever seen. In the past, wars were won by those who had more planes, more pilots, and more firepower. Today, that is no longer enough. The next war will be decided by technology, artificial intelligence, electronic warfare, and advanced stealth capabilities. The fighter jets of the future will not just outgun their opponents, they will outthink them, outmaneuver them, and defeat them before the enemy even knows they are there. The competitors. Who is racing to control the skies? The competition to build the world's most advanced fighter jet is not just about military power. It is about global influence, economic supremacy, and the ability to shape the future of warfare. The United States, the U.S. has long been the leader in air combat technology, with aircraft like the F-22 Raptor and F-35 Lightning II dominating modern air forces. However, the U.S. is now working on the next-generation air dominance NGAD fighter, a secretive sixth-generation fighter jet designed to maintain American air superiority against rising threats. China. With the rapid development of its J-20 Mighty Dragon stealth fighter and the rumored J-31 Gerfalcon, China is aggressively pushing to challenge Western air superiority. China has also invested heavily in hypersonic missiles, AI-powered drones, and electronic warfare systems, aiming to become the dominant air power in the Pacific region. Russia has introduced the Su-57 Felon, its answer to Western fifth-generation fighters. However, reports indicate that Russia is already working on a sixth-generation fighter, incorporating AI control, laser weaponry, and drone integration. Given Russia's historical emphasis on maneuverability and firepower, their next fighter jet will likely focus on high-speed dogfighting and stealth. Europe, beyond the UK-led Tempest program, France, Germany, and Spain are working on their own future combat air system, FCAS, which aims to create a highly connected, AI-powered fighter jet capable of coordinating drone swarms and electronic warfare tactics. This global race is not just about who builds the most powerful aircraft. It is about who creates an ecosystem of advanced air combat technology that will define military power for the next 50 years. The new battlefield. How air combat is changing. The air battles of the future will look nothing like those of the past. Traditionally, air combat revolved around dogfights, missile engagements, and radar tracking. But now, warfare is shifting toward invisible threats, electronic attacks, and AI-driven decision-making. Stealth is no longer enough. While stealth technology once provided an enormous advantage, radar and sensor technology are improving rapidly. The future of air combat will not just depend on making jets invisible, but on actively disrupting enemy sensors and communications in real time. AI-driven combat. Future fighter jets will rely more on artificial intelligence than ever before. AI systems will not just assist pilots, but will make split-second decisions, control unmanned drone squadrons, and predict enemy movements with unprecedented accuracy. Cyber warfare in the skies. Fighter jets will not just engage in physical battles, they will also wage digital warfare. The ability to hack into enemy radar systems, disable missile defenses, and disrupt air traffic control will be just as important as missile firepower. Loyal wingmen and drone swarms. Future air battles will involve not just manned aircraft, but entire networks of AI-powered drones, controlled by fighter jets like the Tempest. These drone swarms will perform reconnaissance, electronic warfare, and even combat missions, reducing the risk to human pilots. This shift in air combat strategy is forcing every nation in the race to rethink how wars will be fought. The military that masters these new technologies first will control the battlefield of the future. One of the biggest revolutions in air warfare is the rise of hypersonic weapons. Unlike traditional missiles, which travel at subsonic or supersonic speeds, hypersonic missiles can reach Mach 5 or higher, making them nearly impossible to intercept. The U.S. is developing the Hypersonic Attack Cruise Missile, HACM, capable of striking targets across continents in minutes. China has already tested hypersonic glide vehicles that can bypass missile defense systems. Russia has deployed the Kinzhal hypersonic missile, which it claims can evade any current air defense system. Fighter jets of the future will need to be capable of launching, defending against, and maneuvering at hypersonic speeds. This is why nations are investing heavily in heat-resistant materials, AI-driven targeting systems, and next-generation propulsion. The strategic importance of air superiority. Air superiority is more than just a military advantage. It determines a nation's ability to project power, defend its interests, and deter conflicts. Controlling the skies means controlling battlefields, protecting borders, and striking deep into enemy territory if necessary. The global arms race is no longer just about who has the best fighter jet. It is about who controls the future of warfare. With artificial intelligence, cyber warfare, drone coordination, and hypersonic weapons becoming dominant factors, the nations that fall behind in this race will be left vulnerable in future conflicts. This is why projects like Tempest, NGAD, FKAS, and China's J-20 advancements are so crucial. These aircraft are not just designed to win battles today, they are designed to shape air combat for the next 50 years. The race for air dominance is reaching a critical turning point. As sixth-generation fighter jets enter development and AI takes over more aspects of warfare, the very nature of air combat is changing. The future of fighter jets will be defined by AI-assisted decision-making that outperforms human reflexes, drones that act as robotic wingmen, multiplying combat effectiveness, weapons so fast they cannot be intercepted, ensuring first-strike dominance, cyber warfare tools that disable enemy defenses before a missile is ever fired, advanced stealth and electronic warfare that make aircraft almost untouchable. The question is no longer who can build the fastest or most powerful jet. It is who can integrate these technologies into a seamless, unstoppable war machine. The fighter jet that wins this arms race will not just dominate the skies, it will change the future of warfare itself. The battle for the next generation of air power is already underway. The nations leading this revolution will control the future, while those who fall behind risk losing their ability to defend themselves in the wars to come. The world is watching, the race is on. The future of air combat belongs to those who can see beyond today and build the weapons of tomorrow. For over a century, air superiority has been the defining factor in military power. From the early days of biplanes in World War I to the stealth jets and hypersonic missiles of today, controlling the skies has always meant controlling the battlefield. But now, as nations race to develop sixth-generation fighter jets, AI-driven combat systems, and advanced drone warfare, the very meaning of air superiority is changing. In the past, air superiority was about having faster jets, better weapons, and skilled pilots. Today, it is about unmanned systems, artificial intelligence, cyber warfare, and integrated networks that function as a single, unstoppable war machine. Fighter jets are no longer just fast. They are smart, self-learning, and capable of waging electronic warfare just as effectively as traditional combat. As the Tempest fighter jet and its global counterparts take shape, the world is entering a new era of air dominance, one where technology is as important as speed and firepower. The future belongs to the nations that can innovate the fastest, adapt to new threats, and build the most advanced war machines ever created. The evolution of fighter jets, from pilots to AI commanders. The fighter jets of the 20th century were piloted war machines, built to dogfight and dominate the skies with raw power and maneuverability. But modern warfare has changed the rules. Fifth-generation fighters like the F-35, J-20, and Su-57 introduced stealth, data fusion, and networked combat. Sixth-generation fighters like the Tempest, NGAD, and FCAS are eliminating human limitations, integrating AI pilots, drone coordination, and next-generation electronic warfare systems. This shift marks the end of the lone wolf fighter pilot and the rise of networked air dominance, where multiple aircraft and drones operate as a single unified force. Future fighter jets will no longer be single entities. They will be part of a larger war ecosystem, integrating swarming AI-controlled drones that fight alongside human pilots, cyber warfare capabilities that disable enemy defenses before a missile is even fired, hypersonic missile technology that ensures first-strike dominance, AI-powered tactical decision-making, making split-second calculations that no human can match. This isn't just an upgrade, it's a complete transformation of aerial combat. AI and automation, the rise of the smart battlefield. One of the biggest changes in the future of air superiority is the role of artificial intelligence. Modern fighter pilots are already overloaded with radar data, incoming missile alerts, enemy positioning, and weapon systems. But future aircraft will be equipped with AI co-pilots that think and react instantly, eliminating the burden on human pilots. AI-driven combat assistance will help pilots track multiple targets, anticipate enemy movements, and recommend attack strategies. Autonomous drone squadrons will follow fighter jets, carrying out reconnaissance, electronic jamming, and even direct attacks without human control. Self-learning algorithms will analyze battle data in real time, adjusting strategies based on enemy behavior. This means that a single pilot flying a sixth-generation fighter jet will not just be controlling one aircraft, they will be commanding an entire aerial fleet, directing both manned and unmanned aircraft with AI-powered precision. Imagine a scenario where a human pilot focuses on strategy while AI co-pilots manage countermeasures, target tracking, and evasive maneuvers. If an enemy jet locks on, the AI immediately detects the threat, calculates the best escape path, and deploys countermeasures before the pilot even has to react. This level of automation and intelligence ensures that the fastest, smartest, and most adaptable force will always win the battle. The future of air superiority isn't just about manned aircraft. It is about unmanned systems that can fight, scout, and support missions without risking human lives. Swarm drones will be deployed in battle, overwhelming enemy air defenses, distracting pilots, and collecting real-time battlefield intelligence. Loyal wingman drones will act as robotic bodyguards for fighter jets, engaging threats before they reach the manned aircraft. AI-powered reconnaissance drones will scan enemy territory, tracking movements and transmitting data back to human pilots. With the ability to control an entire fleet of drones from a single cockpit, future fighter pilots will have unparalleled combat capabilities, turning every mission into a fully coordinated attack strategy. Hypersonic and energy weapons, a new level of firepower. Speed has always been a deciding factor in aerial combat, but hypersonic technology is changing the game. Hypersonic missiles can travel at Mach 5 or higher, making them almost impossible to intercept. Next-generation railguns could replace traditional cannons, firing projectiles at extreme speeds with pinpoint accuracy. Directed energy weapons, laser-based systems, will provide infinite ammunition, capable of disabling enemy aircraft, drones, and missiles instantly. These next-gen weapons will make traditional dogfights a thing of the past. Instead of chasing enemy jets through the sky, pilots will fire weapons that hit their targets almost instantly. With hypersonic speeds, AI-guided precision, and unlimited energy-based firepower, future fighter jets will be the deadliest machines ever created. Electronic and cyber warfare, the invisible battlefield. Fighter jets will no longer just rely on stealth coatings and radar-absorbing materials. Instead, they will be equipped with next-generation electronic warfare systems that can jam enemy radar, making the aircraft disappear from detection, disrupt enemy communications, cutting off their ability to coordinate attacks, hack into enemy systems, disabling missile defenses and air control networks before the battle even begins. With these capabilities, the future of air combat won't just be about who has the best fighter jets, it will be about who can control the digital battlefield. The race for global air superiority. As technology evolves, nations are investing billions into air superiority programs. The global arms race is now focused on who can create the most advanced fighter jet ecosystem, a force that combines AI-assisted aircraft, drone coordination, hypersonic missiles, cyber warfare capabilities, directed energy weapons. The country that masters these technologies first will control the skies, and, in turn, the future of global security. The next war will be fought in the sky. The future of air superiority is not about individual jets or pilots. It is about a fully connected war machine where human intelligence, AI, drones, and cyber warfare work together seamlessly. Imagine an enemy force preparing to launch an attack. Before they can even take off, their radar systems are jammed, their communications are hacked, their air defenses are neutralized by AI-driven electronic warfare. Their fighter jets are intercepted before they ever see their attacker. This is the future of air superiority, a battlefield where the enemy is always blind, always confused, and always at a disadvantage. The ultimate weapon, innovation. The future of warfare belongs to the innovators, the engineers and the strategists who can think ahead, adapt faster, and develop the most advanced technology. With AI-controlled aircraft, next-gen weapons, and digital warfare, future fighter jets will redefine military power. The skies will belong to those who lead this revolution. The question is, who will dominate the future of air combat? The answer will decide the balance of global power for the next century.